Welcome everyone to this video where we are going to study the basics of quantum computing. My name is Sukhmandeep Singh and this is my assignment for Signals and Systems class. Let's get started. Now, first thing, let's introduce ourselves as to what we are going to be doing over here. In this, we will cover the basics of quantum computing, only the basics. First, we will describe how traditional computers work, and then we're gonna go towards the basic working of quantum computers, and then we will compare the both and find out the advantages of each type on the other and what both of them are used for. First, let's look at the working of traditional computers. Traditional computers and supercomputers work on bits that process through algorithms. These bits follow the binary rule. They exist in one state at a time, that is either 0 or 1. Now they cannot stay in multiple states at one time. They go through the algorithms one by one. You will have a bit. They traverse through operations and compute according to the algorithm programmed for them. Moving on to how quantum computers work. Quantum computers, just like traditional computers, use bits that carry value 0 and 1 and go through programmed algorithms. But they do it through special bits known as quantum bits, or more popularly known as qubits. These are special bits that remain in both 0 and 1 at the same time due to what is called superposition and work with each other through quantum entanglement to go through algorithms faster than normal computers. We'll look at both these terms, superposition and quantum entanglement, more. First, let's explain a little bit more about qubits. Now, a bit exists in either of two states, either 0 or 1. Let's take it as either a top spin and a bottom spin. In this example, as we have here, we have a bit that is 0 and we have a bit that is 1. Now over here we see that the 0 can exist in one single state and the 1 exists in one single state, but a qubit, following the phenomena of superposition, exists in both 0 and 1. Now let's go to superposition as to why this happens. So now superposition, mentioned before, is how the phenomena of qubits exists even. Superposition allows a bit to stay in two different states at the same time. This means a qubit can represent multiple possibilities at once, a capability leveraged by quantum computers to process information in parallel and solve complex problems much faster than classical computers. Qubits now also follow a certain rule to work with each other, as mentioned before, which is called quantum entanglement. Quantum entanglement. Quantum entanglement of qubits is a quantum mechanical phenomena where two or more qubits become correlated or linked in such a way that the states are interdependent regardless of the physical distance separating them. What this basically means in layman's terms is when distances get so small as to let the quantum take effect. So things such as physical distance stop mattering between two qubits. When one qubit, displays a single state, the other qubit connected to it through entanglement are going to display the same state as well. Thus, if a single qubit was changed in its state, every other qubit connected to it would change instantaneously. When entangled, measuring the state of one qubit instantaneously reveals the information about the state of others, enabling quantum systems to perform complex computations and communications with capabilities beyond classic computers. As you can imagine, as you can imagine, the entanglement makes the qubits change each other instantaneously, thus making communication just that much faster and helping the qubits get through algorithms that much quicker than classical computers. Let's look at the comparison or the difference between the traditional computers and the quantum computers. Traditional computers use bits, that exist in one state at a time, whereas quantum computers use qubits that can exist both states at a single time due to superposition, as mentioned before. Traditional computers are better for everyday tasks, such as surfing the web, watching videos, making presentations or something, graphs. Whereas quantum computers, because of their extremely high computational power, are better for solving complex problems that require multiple pathways to solve and to do it faster, much faster, exponentially faster than traditional computers would. This, such as an example could be like integral fractions, probably, which would take a lot of time for a traditional computer to do, which would be done much faster by a quantum computer. Traditional computers, though slower in solving complex problems, quantum computers aren't faster than them all the time. They can be slower in algorithms that do not require extreme computing powers, such as reading emails or surfing the web, as said before. Now, let's take an example or two to properly understand how both these traditional and quantum computers work. Imagine a chessboard. You're playing with your friend, and to predict his move, you are going to use a computer. You have two computers now, a traditional computer and a quantum computer. You use a traditional computer that goes through every single possible move one at a time. Per se, as you can see over here, the traditional computer takes one single move at a single time. If not this, it would have taken, oh, okay, let's say this one move, and it will come back and take this one move, or come back and take this one move, or it will come and take, oh, okay, this is one move we can do, or this is one move we can do. As you can imagine, is extremely time consuming. By the time it finishes iterating or checking the permutations of every single move that it can do, it would take a lot of time. But then you have what is a quantum computer. A quantum computer is going to look at a piece and it's going to do all its single combinations and permutations at a same time. This makes the process exponentially faster. Where it took the traditional computer to calculate one move, it has taken the quantum computer that much time to calculate multiple moves at the same time, thus improving the time and reducing the time and improving computational power of the quantum computer, making it much easier. Another example we could take would be, let's say you have a maze and you have a traditional computer and a quantum computer. Now you know in mazes there is only a single path which is correct. You use a traditional computer which would take one bit and it would go through every pathway, and it would go through every possible pathway that is there, hitting walls, coming back, and it would go and come back and then do another pathway, then come back and do another pathway, which obviously, as you can imagine, is time consuming. Whereas if you put it in a quantum computer would simply use qubits and go through multiple pathways at a single time, which, as you can imagine, is much less time consuming. I hope this was enough to show you the basics of quantum computing. Thank you for watching.